The first two types of factoring we dealt with in these sections, the x squared plus bx plus c and the ax squared plus bx plus c, they were just simply, they were processes that you would go about, following to factor those, right? Now here we have special forms of factoring, and these really, you kind of just have to memorize these. I mean, there's really no way around it. You pretty much just have to memorize the forms, okay? And what are these forms here? They're the difference of two perfect squares, the difference of two perfect cubes, and the sum of two perfect cubes, okay? And then I have a little note at the bottom there that says the sum of two perfect squares cannot be factored using real numbers, right? So the difference of cubes, the sum of cubes, both factor, but only the difference of squares factors, right? Only the difference of squares factors, not the sum of squares, right? So here's the forms. There's your form for the difference of squares, right? A squared minus b squared. And I mean, you can see why it's called difference of squares, right? Difference meaning subtraction. And what do you have? You have a squared and b squared, right? And then here's the difference of cubes, right? Again, it's because it's subtraction and you have cubes. And then the third one is just the sum of cubes, right? Because it's addition and you have cubes, right? So again, it's just really fitting the forms. I mean, I'll go through these examples, and I'll identify, like what A and B is in each of these cases, but it's really just a matter of knowing what the form is. So the first one is 16x to the fourth minus y squared. All right, well, they're definitely not perfect cubes, right? But they are perfect squares, right? So in this case, you know that a squared is really 16x to the fourth, and b squared is really y squared, right? So we have 16x to the fourth as a squared and y squared as b squared. So if a squared is 16x to the fourth, what would a be, right? Well, how do you get from a square back to the first power? You take the square root. So what's the square root of 16x to the fourth? It would be 4x squared, right? You're chopping the power in half. When you take a square root, you chop the power in half. And then the square root of y squared is obviously just y, right? So what does this factor into now? Just look at the form. It says the form is a minus b times a plus b. Well, I know what a and b are now, right? A is 4x squared, b is y. So I know this thing is just going to factor into sorry, not a. A is the form, right? It's going to factor into a, which is 4x squared, minus b, which is y, times the same thing, just with a plus sign in the middle. 4x squared plus y. Okay? And the reason this works, if you multiply it out, is when you multiply this out, what ends up happening is if you call it FOIL, the OI part of FOIL cancels, right? The OI of FOIL are opposites of each other, and so they cancel out. So 4x squared minus y times 4x squared plus y would be example 8. All right? And then 9 and 10 look like they're cubes, right? So 9 should be the sum of cubes. So in 9, a cubed is 125 z to the 6th, and b cubed is 8y to the 9th. And what ends up happening with cubes, any power that is a multiple of 3, 3, 6, 9, 12, 15, 18, and so on, those are all perfect cubes, right? Any even power is actually a perfect square, but any power that's a multiple of 3 is going to be a perfect cube. So if a cubed is 125 z to the 6th, that means that a is really, well, the cube root of 125 would be 5, and the cube root of z to the 6th, you're dividing the power by 3. So it's z to the 6 over 3, which is really z squared. So a is 5z squared, and then this one here, b, cube root of 8 is 2, cube root of y to the 9th, again, y to the 9 divided by 3, so it's y to the 3rd. So a is 5z squared, b is 2y cubed, and now again, just plug it into the form. The form says a plus b, right? So a plus b would be 5z squared plus 2y cubed. And now I have a trinomial, actually, 3 terms. And if you don't want to try to memorize this form, what's not a bad way that I usually tell people to try to remember it is, this is a plus b, right? So then the second factor, which is a trinomial, becomes this thing squared, which is 25z to the fourth. This thing squared, so 2y cubed squared, which is 4y to the sixth. And then what ends up happening in the middle is you multiply them and you take the opposite sign. So it ends up being 5z squared times 2y cubed, which is 10y cubed z squared, but you change the sign. So it becomes negative, and I'm going to have to erase this and fix it, right? It becomes negative 10y cubed z squared, right? And I had a positive 4y to the sixth over there, right? But again, even if you're not 100% sure that you're factoring it correctly, that's why it's nice to always be able to multiply it out, because you can check and make sure that when that gets multiplied out, it does equal to what I started with, right? It does multiply to what I started with. And again, what ends up happening here is the only thing that you end up left with is this times this, and that times that. All the other ones end up canceling out, right? All the other things that get multiplied end up canceling out. So that was the sum of cubes. And then the last one, example 10, is actually a difference of cubes. So 27x cubed minus 1, this one is a little bit easier actually, right? Because in this case, a cubed is 27x cubed. B cubed is 1. So again, what's the form? Oops, sorry, I don't want the form yet. I want to identify what's what, right? So if a cubed is 27x cubed, that means that a is, the cube root of 27 is 3, and the cube root of x cubed is x. And if b cubed is 1, that means that just b is 1, right? So that's what you got. You got a is 3x, and b is negative 1, right? So what is this going to factor into? It's going to factor into a minus b now. So that's easy enough, right? 3x minus 1. And again now, trinomial. And what happens? Square 3x, I get 9x squared. Square 1, I get 1. And now what happens in the middle? You multiply the two of these, so you get negative 3x, and then you change the sign. So it becomes positive 3x. Okay? So that's 3x minus 1 times 9x squared plus 3x plus 1. All right? And that would be your a minus b times a squared plus ab plus b squared. So that would be the difference of cubes. But again, it's just practice. I mean, you can't just say, oh, I know the form, done. Right? You actually have to do a few of them. And that's why we have the you try it's here.